Welcome back to blockchain technology and applications, another lecture. So last time we were talking about Ethereum blockchain and what are some of the differences between Ethereum and Bitcoin, and one of the difference we saw is the difference between how the state is maintained in the blockchains. In case of Ethereum, it is based on accounts, and in case of blockchain it's based on UTXOs or unspent transactions. Now the question, remember that in case of the block, how the blocks are kept in the Bitcoin, we talked about Merkle tree, right? So in Merkle tree we have a very specific data structure which basically is a hash tree. Now Merkle tree is quite a bit of work to find a particular transactions for a particular account. For example, in case of Bitcoin, in case of Ethereum, so they use something called a Patricia Merkle tree. And so Patricia tree is a data structure which is actually based on the idea of a prefix tree or radix tree or trie. So the idea there is that I want to save space, but I want to record a number of different strings. Let's say not everything is not necessarily strings, it may be other objects like account addresses and information like that. So the question is, how do you store them? So in a trie, what happens is that if you have number of different, let's say, strings, and you don't want to, so if you want to store the strings in a Merkle tree, for example, then if you have let's say 100 strings, then you will have 100 leaves, each of them will be storing the string, and then 2 of them will be hashed, and then another 2 will be hashed. So you will have a height of log of 100, which would be about height of let's say log of 100 will be about close to maybe log to the base 2 is 7. So you might have a tree of height 7, and then all the different things. Also, finding something there, unless the leaves are sorted, will be quite a bit of work. You don't know when you start from the root which direction to start. So the idea of trie is that you keep the prefixes of the different common prefixes on the path. So for example, suppose I want to store these strings 2t, ted, 10 and in, right? So in this case, what you would do is that we see that there are 4 of the strings starts with the same prefix, so t. So I will create a root, and then I will have a child which is marked, whose path is marked with t, and then I will have a node for t, and then I see that after t there are 2 with e and 1 with o, and actually 3 with e. So therefore I will create one branch with e, and then it will be te, and then I will be easily create this t, ted and 10, and then you will have this one which is 2, that is separate. Similarly here you will have let's say there was another word a, so a is alone here, and then you will have this one in was different, so in, then n and in, this will stand out separately. So we have basically used a prefix encoding in creating the data structure, and therefore if I want to search TED, I know that I have to go in this direction, go in this direction, and then go in this direction. So the searching will be log n, and it will be even sometimes if you have much more commonality in the prefixes, it will be even easier. So this data structure trie is used for implementing, for example, routing table and routers and so on. So this is not something new that is being invented here, but they decided that this is how they are going to store the account informations. And then Merkle tree you already know, so there is nothing new to discuss in Merkle tree. So if you want to keep different data, then make them the leaves, and then you start making hashes and get the hash. The root hash will give you integrity of the entire thing. So they combined the idea of Markov-Patricia tree as the data structure through which the blocks are stored. So, since we are not going to really work on the blocks per se, I just want to give you an idea that this is another different optimizational aspect of Ethereum compared to the Bitcoin blockchain. So, now what I want to do is I want to tell you how to go about playing with Ethereum blockchain and creating your own network, so that you are not initially having to work with Ropstein or certainly not on the mainnet. You create a simulated Ethereum blockchain on your machine using something called Ganache, and then you use Trueful, which will be used for creating smart contracts and applications and the ability to deploy contracts. So, what these things will give you is the ability to very quickly get started with creating smart contracts. For example, you want to create some smart contract like already skeleton smart contract available, let us say, and then you want to fill that in a little bit to create some functions in the smart contracts and play with it. So, what I would do is that I will assume you have an Ubuntu. Otherwise, what you can do is that you can download a virtual box from from Oracle. It is a free software virtual box. You can Google it and then you can download it. It is basically a virtual machine, ability to host a virtual machine through VirtualBox. Then Ubuntu distribution sites, and you can download Ubuntu let us say 19 or 18.04 LTS, whatever is the version you want to get, and you get a ISO image. It is going to be pretty heavy, couple of gigabytes, but nowadays that is not a big deal. So, you download that and then you create a guest machine in the virtual box with Ubuntu, and then you can use that as your experimentation machine within your let us say Windows machine. Or what you can do is that you can find the instructions for creating Node.js and installing Node.js and Trueful and Ganache on your Windows machine. I have not done that, but I am pretty sure you can find how to do that on the internet. So, but I am going to assume that you have Ubuntu. So, you have to update your Ubuntu first and then install Node.js, and Node.js is actually a development environment for JavaScript applications, and then you install the Node package manager, which will allow you to do various things like install Trueful, install Ganache and so on. You want to check the version of NPM, it is 5.0 plus is good. Then you use the package manager NPM to install three things, Trueful, two things, Trueful and Ganache, and then you Ganache will also create an account Ganache. So, you actually do this. Now, when you start Ganache, right, so you will see that it basically is starting to emulate a Ethereum blockchain, which has already pre-configured 10 accounts 0 to 9, and their addresses are given here. You may actually record this, copy these addresses to a file and the corresponding private keys. So, these are the private keys, and then you have the gas price here. This is in terms of V, and then there is a gas limit, but this gas and gas price and all that stuff is going to be fake, because this is not against the mainnet. So, you do not really have to pay any money, and then it will start listening for nodes to do things at this port 8545. So, this port, so when you deploy a transaction, it has to refer to this host and this port, so that you can this it goes to this Ethereum emulation, and then you will see the effects of deploying a contract or testing a contract and so on. So, then in order to then you open a different window, because that window will now be busy listening to for nodes to deploy contract or do transactions there. So you make another window and then you create a demo directory, you make a directory name and go to that directory and then say truthful init, right. So what truthful init will do is that it will create multiple different directories, and these directories are called contract, migrations, test and so on, and these directories will have some skeleton code for the contract called hello world. It does not know what you want to do with hello world, so that is what you have to fill in, but at least you will it will put out the skeleton. So as you can see here, this is what we are doing, and then truthful can also be used to compile contracts. It can also use to migrate contracts, which basically leads to deployment, and then you can do the testing of the contract. And once you have run the truthful init, you will get this directories under hello world contracts where the smart contract code will be there. Migration is the migration code for deployment, because when you create a smart contract, you also have to create JavaScript or whatever to actually deploy the contract or call functions on the contract and so on. There is a test directory, and there will be configuration JavaScript files, and now you have to start working with this. So if you look at this thing, then you will see that you have hello world, and the hello world has contracts in which it will have one smart contract for migration called migrations.sol, and then you have a JavaScript in the migrations directory which is for the initial migration, and then you have this configuration other stuff. So contracts is where you store the Solidity code of the smart contracts. Now we will create a hello world.sol file and put in the contracts and fill it up. Migrations is also another smart contract that is going to be used to deploy this contract, and test is a test code, and it can support both JavaScript and Solidity. And truthful.js is a configuration document, and truthful.js actually is already filled with everything commented. So you have to uncomment the configuration of the network, and in your case the network is listening on port on local host, that is 127.0.0.1, and then it is actually listening to port 8545. So you have to make sure that you uncomment that network configuration in which the port is 8545 in this file. This file you can is only for Windows users or old Ubuntu users, so you can ignore it. So now you do this create contract hello world, and then it will create a skeleton for the hello world.sol, which will have the skeleton code where you have to fill things in. So this will look something like this. So pragma Solidity, this says what is the version of Solidity. Solidity is a evolving language in last 4 or 5 years. So right now I think it is 0.7. So currently, so this is from last year, so most probably you will see something like 0.7 or something here. And then in the contract hello world, you will have there will be a constructor. Automatically you don't need to do anything in there for this particular example. A constructor is what actually initializes the contract, and it only gets called when you first time deploy the contract. But if the constructor is skeletal, which basically means that it is not doing anything, but in this case we want another function which basically does not take any input, but it returns a string, and this string is actually of type memory. So it is not in the storage, it just in the memory, which means that this will not be stored on the blockchain, and then it will return hello world. And then you can call truthful compile, and this will compile the hello world.sol into bytecode. Now it also creates a JSON file which is in the build. So you will see a build directory that has come up, which was not there when you just created did the truthful init. So, you will see that JSON file in there, there are some of the configuration information, and you do not have to worry about it for this simple contract. And then in the migration directory, you create another JS file, JavaScript file. Remember, there was already a 1 underscore initial migration file. So, now you will be creating a 2 underscore initial file, and in that case, in there you are going to say, so it is a JavaScript. So, there you are going to say that I have this variable hello world, and the artifacts required for this is the hello world.sol file. And then it will say module.exports equals function deployer. So, it requires a deployer, and deployer deploys this smart contract. So, the name of the smart contract is hello world. So, it is going to deploy this. So, when you run this JavaScript, it will deploy based on the configuration information that is already in the truthful.js and so on. So, as I said that in the truthful.js you have to make this uncomment. So, mostly they will come commented like this. So, you have to basically uncomment the relevant part, so that you know that your host on which the network host is localhost, and then the port at which it is listening is this, and then you call truthful migrate. And remember, there was a window in which the Ganache was running, and it was stuck at the point where you left it. So, now as soon as you migrate, you will see that it will tell you what is being deployed and all that stuff. So, you will see all these things in the migrate. This kind of information, the contract address and so on will come in that screen where you have the Ganache running. This is actually the what you will see in the Ganache screen, where you will see all this different things being invoked, and these are the transactions, block number, and so on and so forth. So, now you can try this. You can also go to the ethereum.org website, and you can actually directly play on the through the web interface. So, they have a hello. If you go a little bit down, you will see a hello world. There will be a coin smart contract DApp. So, various DApps are there. You can also play with that instead of having to do all this yourself. But I think it is more fun to do it yourself than going there, and because the amount of visibility of what you are doing, it will be slightly less when you are doing it through the web interface. But you can do that also, and you can see number of different contracts to learn how the contracts look like and how they work and so on. So, in this set of lectures, you learned the design philosophy of Ethereum blockchain, some basic differences between Bitcoin blockchain and Ethereum, the concept of smart contracts, the concept of Ethereum network and simulation of such network for testing, and finally, a clue about how to simulate a local private network and try out a simple smart contract on your own. So, in this course, so we are about 4 weeks away from the end, and we have to cover a lot of other things. So, next thing that I want to cover is some of the issues that this Bitcoin and Ethereum, this permissionless and cryptocurrency blockchains have, that we have ourselves at our laboratory have discovered, and I want to actually make you aware of those. Because as you know probably that RBI had put a restriction on cryptocurrency buying and selling in India, and then recently in last week the Supreme Court has asked RBI to enable cryptocurrency exchanges and cryptocurrency selling and buying and so on. And I personally has been very critical of that step, because in a country like India, where people can be easily fooled and they are not so aware, there are a lot of things about Bitcoin and blockchain that people do not know, and they might actually lose money because it is very speculative, and therefore I want to give you some little more idea from our own research as to why I think that cryptocurrency is not something that should be bought and sold in India. So what we are going to do is I want to start talking about this, and eventually we'll talk in details. So first thing that I want to say is that we have studied the entire Ethereum blockchain until last year's April. We basically downloaded all transactions, all smart contracts that have been there since 2015 to 2019 April, and we analyzed how many contracts are involved in most of the transaction, how many contracts have most of the ether, how many contracts have most of the activities, and we find that there is a huge amount of inequality in the Ethereum smart contract, and we are doing this because Bitcoin, similarly Bitcoin blockchain information has been similarly analyzed, and people found very similar patterns, and we wanted to see if Ethereum has the same. And remember that the idea that the blockchain was put forth in the first white paper by Satoshi Nakamoto is that he wants to create a more just currency system and transactional freedom, anonymity, and all the government lack of government interference and so on. But we find that the real social inequality that we are seeing in real economy is being reflected here almost entirely, and probably even more. So what I want to show you very quickly, and go over this after in the next session, but I want to show you some of the results. So what we have found is, so until last year we collected all the blocks. So there were 7 million blocks, 7.1 million blocks at that time. There were almost 400 million transactions, about 760 million addresses, 44 million unique addresses among them. These are addresses that are referred in transactions. And then smart contracts, we found 1.9 million smart contracts, and out of which we found source code for about 53%, because there is some authors of the smart contracts also put their source code, whereas the other ones they don't put their source code. So we did this. So we finally we collected 1.9 million smart contract bytecodes, out of which half of which we could find the source code. But for what I am going to tell you now doesn't require source code. So what I am going to show you is that, so it is observed that out of 1.9 million smart contracts, 94.6, that is 95%, are duplicates. So about 0.1 million, that is about 100,000 or so smart contracts are actually original smart contracts. Most duplicated contract is of course the user wallet contract, which has about 650,000 instances. Only 2 out of top 10 contracts which duplicated, like when I say top 10, I mean the ones which have been duplicated the most. So user wallet is the most duplicated, and then the fourth duplicated is forwarded. These two we got the source code. Now it observed that top 100 contracts, that is only 0.1% contracts out of the 100,000 original contracts, they actually get duplicated about 1.72 million. So that means that 90% duplication are only in about 100 contracts. So diversity of contracts is very, very low. And then we have wanted to see balances, right? So we found that top 100 contracts contain 99%, almost 99% of the Ethereum. So this is what we are worried about in real society today in the economy, that like 0.1% of people actually control, let's say 70% of our country's assets, and this is true in the US and other countries as well. So this is an inequality that is worrying economists. and we would have thought that this Bitcoin and Ethereum, these things will liberate us from such inequality of the society, because there is integrity and all that stuff, but actually that's not happening. So only 100 contracts basically own 99% of the ether. So this is very, very worrying thing. And we saw that smart contracts on our data set were involved in 175 million transactions, of which is 46% of all transactions. And we found that the 2,500 contracts are responsible for 90% of the transactions. So which means that if it's not 100, but it's still only 2,500 contracts which are doing most of the transactions. So which means most of the accounts are excluded. So I will go through this in even more detail in the next session, but what I want to caution you about is that this idea that blockchain and this pseudo-anonymous blockchains will free up free society and all that stuff is not happening. And this is not only in Ethereum block, other people have done similar analysis, and they have seen similar trends in Bitcoin blockchain. So we'll discuss this in more details before we go into permission blockchain for the next several weeks. So but I think that this is something you should keep in mind when people advocate cryptocurrency and cryptocurrency based society and all that buzzwords. Okay, so we'll see you next time.